Hi, today I'll be discussing a topic which is very important for interviews, and many software developers and senior software developers struggle on this specific topic. And I have personally faced it in several interviews. So I thought of sharing my experience as well as finding and providing a clear way of getting through it. So without further ado, let's just move to the topic. So my topic is like I failed multiple system design interviews, and then I'll be discussing this using a Daraz example, what a system design itself is and how we can effectively uh, pass our system design interviews. So moving to the actual, okay. So I have appeared in several interviews, and what I personally faced, these system design questions, they come as a very generic question. And if you do not have practiced it and you do not have a perfect answer upfront, so there's more chances that your interviewer is not going to get impressed, and he might feel that you haven't worked on like big systems, or you might not have worked on systems end to end. So a person can ask you either you have designed a document system, or he can even ask you like either you have a build up the Rascalone or any Uber or any big system. So they can throw a simple question at you. And what actually happens with me, I somehow managed to answer those questions, but those were not very up to mark and what actually the interviewer is looking for. So I used to give certain vague or unstructured answer because I wasn't very well prepared for those type of interviews. So let's just ask what a system design itself is. So when we talk about a system design, like when we prepare for interviews, what we used to do, we just focus on our tech stack, either .NET, Angular, Java, whatsoever. So we just take and keep in consideration these questions which are related to our tech stack. But we think the system design and we take it's very lightly that we can just pass it. And this is, believe me, it's a most underrated and under anticipated area. If you are not good at it, so you might not be able to land into any senior or leadership level position. So make sure you are extremely good at this. And how you can be good at this, it's by reviewing the things, getting around the things, trying to see what other components are there. So moving further, think of it is like if coding is like building an individual room. So what the system design is like designing the entire building. So what you need to think through, like if you are just designing an individual room or building an individual room, you do not need to like cater what other rooms are going to do and how people are going to move and how other things are going to operate. But if you are designing the whole system, so you need to consider everything. What's the location of the room, how the people are going to move between them, how many floors are there, and how many floor can be sustained. So you are thinking from an architectural perspective. So this is again a mental model shift. Then comes what interviewers are looking for. They are not only testing that you are able to code or write, because nowadays with the advent of AI, it's very easy to give a proper prompt and you can get a very like well written code at your disposal, and which is way better than the 10x developers out there. So you need to think about how large systems are going to work at a scale. So these are the like three questions which like a system again from a system design point of view, interviewer might going to ask. One is like requirement, what does the system need to do. So these are the basic requirements. Then comes the architecture aspect, how we are going to build it to sustain it over a long period of time. And then comes the main thing, like every business wants to scale and wants to grow. So then the question comes how we can scale it with millions of users. So these are the things which like interviewers are looking for. So if you are able to answer them, those questions, you are likely to succeed in those type of interviews. Now talking about like understanding the requirements, you need to if you have been thrown a question, let's say if someone asked you to build a system like Uber, or build a system like Kareem, or Daraz, or somewhat which is a high scale system. So you first need to ask some clarifying questions, like you need to identify the type of requirements. One is a functional and the second is a non-functional. So when functional requirements comes, so what does it mean? Like you need to ask what the system does. User can browse and search for products, seller can list a product with images and price, and user can add items to a cart or not. Payment can be made by a card, easy paisa, or like delivery. So these are the type of questions you need to think through. And then user gets like order tracking or not, or any notifications, and how the products are going to get managed. So these are the basic level questions. These are the type of requirements, and usually we are good at it. We are able to ask about the question. But then comes the non-functional requirements. And what's the requirement of this? Like how will it does it? Let's say a system should scale or handle 10 million daily active users. So these are sort of a non-functional requirements, like product search should result within 1 second. The system should have 99% uptime. So these are the questions for which you need to see the infrastructure aspect of the things, how well the components are interacting, what sort of architecture you are going to build, and how you are going to do it. Then comes the payment processing. Is it going to be secure and consistent? No double charges are getting like being triggered for anyone. Let's say if I'm placing an order, I should not be charged twice. So let's come with the high level architecture overview. So I'm focusing on Daraz application. So let's say if an user opens Daraz, you need to think through from a product perspective first, like how the user is going to interact with the app and what is going to actually happen behind the scenes. So what actually happens when a request, when I open, let's say I just pick up my phone app, or have opened the browser on my system. So I just tried opening the Daraz app. When I just typed in that Daraz URL, it's going to hit the API gateway. So think it as a front end gateway or front door of the building. So this is where every request is going to land. Behind that door are like many specialized microservices. So when we see microservices, there is a paradigm shift over a period of time. Previously, there used to be like monoliths and just one big application having all the like services or endpoints, I would say, in a same application. But that was hard to scale. So one more thing you need to consider and keep in your mindset is that when you are talking about big systems and high level architecture of a somewhat like this big system, microservices do play a major role. So you should be well versed in microservices as well. So, and I'll be discussing about how we can like segregate our domains into microservices. So with each microservices, it's doing its own thing. Like order, search is a different microservice, searching for a product, and payment processing is a different. So we need to identify any specific market microservice that we are going to scale. Then comes the service has its own database storing what it needs. Like each service is going to have its own database, so we can scale it individually. Then comes a content delivery network. Like if we are using Daraz, so content delivery network is a like I would say a network which serves your images or any such type of contents in a very fast manner. They have their own way of caching and they can serve it from there. So having this will help you serve your images faster without bogging down your actual infrastructure. So, and then comes one more thing. Like when we talk about microservices, there also comes another concept, which is again a high level concept, and at times people might not have used it. And this is like message queuing. So every service as it's going to be an individual service and it's going to have its own database. So the way they are going to talk with each other, or the way they are going to use each other, is using a message queue. So there are like multiple messaging queues out there. Not going into a specific detail. I'm trying to give you a high level architecture. So let's just see a high level architecture in terms of the visual appearance. So if we are having a Daraz application, so you can see the client can have a web application, it could have a mobile app, and one more thing is like a seller portal, like where the he is going to upload the product. So it is more of an administrative, and it could be again a mobile app and could be a web app. So all these are like front end client apps, and where the calls or the API calls are going to get landed, it's going on to get landed on a gateway. What does an API gateway means? Because API gateway is a front end gateway. You can think of it as an Nginx, or think if I want to make it more easy for you, think of it as a front end door where everything is landing, and this is the main checking point where authentication have been identified, like if the user have been authenticated or not. Rate limiting is being done over there. Rate limiting means if like any services or API calls are coming at a very high rate, so API gateway will return with a specific HTTP code rather than bogging down the whole system. So rate limiting is used for that. Then comes the routing. If a specific like request needs to be routed to a different service, so routing works there. And one more thing, SSL termination is also at the same point. What does it mean? Like when you are connecting with a client and a gateway, so basically these are done over public internet, so you need to secure the connection, and for securing that connection, the SSL certificates are used to make like your communication secure. But beyond that, all the infrastructure is within a like managed infrastructure. That's not a public infrastructure. So at this point of time, SSL termination have been done, and post that, other services can operate on a normal HTTP calls without having this SSL certificate. The reason is that because when SSL is being used, there is an additional cost for like SSL negotiation, and then the way it performs. I'm not going to go into much detail. If someone needs to like ask for it, please feel free to comment. If I haven't explained any topic in detail, feel free to comment. I'll add more videos on that. Then comes to the services part. If we talk about the Daraz service, like Daraz like portal, so there could be multiple services. When you are going for an interview, so any if you came across any product which they have asked like design this, so you need to think through like how we can create multiple services over there. One thing is that most of the time the application that you are going to use is going to have a user service, because user will always be there. So think of keeping this as a default thing. So you can say that we need to create a user service via which we are going to issue JWT tokens. JWT itself a new topic. I'm not going into detail, but by using this, when the user is authenticated, a JWT is being provided, and which is going to be used later with the other like API calls. So this is one service you can keep in your mind from an interview perspective. So user service is going to be there always. Then comes the catalog service. If it's a like the last type application, there is going to be a product. So most of the time there might be some sort of catalogs. It could be something else if you are doing for any other specific thing. So the service might change. But for any e-commerce service, be it Daraz or be it Amazon, there is going to be a catalog service. Then comes the order. Order is not just specific to the e-commerce application. It could be any order processing system or any system that takes order. Even in a restaurant business, order is going to be there. So you can create an order service as well. So I just told you like three services you are able to create as of now, rather than just thinking about how we are going to break it. So user service is going to be there, catalog service is going to be there, order service is going to be there. Then comes the payment service. Each and every entity or website or such type of business over there on the internet, they want to perform some actual transactions. So then there comes the payment thing. So payment itself is going to be a service which is going to get integrated with different type of services, Stripe, cash on delivery, any banks or anything. So this again a fourth the service. Then comes the search. It's itself a service. Why the search is being created as a specific service, I will tell you later in coming slides. Then comes the notification. Notification is again one of the main area, and in most of the systems it's being used. Like everybody wants to be notified about their order, either via email, either via SMS or push or any other channel which might came across. So with this you might be able to properly dissect multiple microservices rather than staying on a monolith. Then comes the event bus. This is a key part, and this distinguishes a not small system from a bigger system. What actually happens when we do have multiple services? So all these need to be interact with these to interact with each other at any given point of time, but they are not interacting directly. They are interacting via a event bus like Kafka or any other event driven this system like RabbitMQ or something else. The focus is not in the specific system, but the reason is to tell how it decouples a circuit service. What actually happened? Let's say if user service is performing certain things which requires something some other actions to be performed by catalog or order. So a specific event have been registered in this event bus, but and when the other service feel free to process it, or at least it's not it's available, the right word would be say it's available. So then the other service process it. So it means like these services are decoupled, and one service, let's say if a search is way faster and search is coming at a very higher rate, so it's not going to bog down any other service because it's not interacting with that service directly. So this is the main reason for having an event bus system. So we will be discussing it in further detail if need be in the upcoming slides. Then comes the actual storage. Even storages are like of two major types. One is of a relational database. It could be like PostgreSQL, MySQL, SQL Server. These are all relational databases. They do have proper table structures and have foreign keys and these and those, but they do have their own trade-offs. When I talk about trade-offs, these are the main things which interviewers are looking for. They want to know if you are able to pick and choose between two things, and you are well aware of the trade-off of a system, why we choose one database system over the another. So this one is a relational database, and then comes a document database. MongoDB, you can see for catalog we are using MongoDB. For orders we are using, for order and user we are using PostgreSQL. So the reason we are choosing a relational for orders because we need consistency. The relational system, RDBMS systems are very good at keeping the integrity of the transaction. There is a word named ACID. I'm not going into the detail. You can look for it. So ACID help you keep your transaction durable in a sense. So it's a like I would say you are very sure that your transactions will stay there and your data is going to be very consistent. Then comes the document database, which is MongoDB. It too comes with a trade-off, but it do provide a very easy way of doing things. Let's say if we have a product and Daraz is serving multiple type of products. It's selling clothes, it's selling like headphones, any like accessories. So what actually happens? the product might be having different attributes. And if we try to fit in within a relational database, we might end up creating multiple columns. So that there comes the real advantage of having a document database. You just have a JSON sort of a document and you just fill it within the document database. So MongoDB again is one of the main thing. If you are going for system design type of things, MongoDB and the document database is a very well used and it's industry standard. So you should be well versed around this, how and when we are going to use, if you haven't used it in your existing or previous professional projects. So that's one thing. Then comes the Redis. Like database calls are themselves a bit time consuming and latency is much higher. So Redis is a caching layer. It's being used as a caching layer. So keeping the current sessions are being done using the Redis. So it helps us improve the overall performance of the system. Then comes one more topic, and then this is Elasticsearch. Elasticsearch itself is very good at curating different type of search queries. We can search a specific thing from the MongoDB, but or a relational database, but it doesn't provide that specific way of searching. So this is another thing that comes up. And again, when you're talking about big system, this type of things and addressing or stating these type of things will really help you, because these are not being used in small systems. Hopefully you are able to follow along with me. Let's just move to the further thing, the key architectural decisions. You could have been asked like, why microservices over monoliths? So the reason, you could have been asked like, why MongoDB for the product catalog? I have just, as I've just mentioned, like having different reasoning for having different attributes, you can use MongoDB for the documents. Then it's again asking for why Kafka between services, which I've already explained. Then it comes asking Redis, which I just mentioned, like for caching. Then comes the Elasticsearch, which I again mentioned you, like it's for searching, and the API gateway job, which I've already explained in very detail. Then comes why microservices over a monolith. So Daraz, if we are now, I'm going to be very specific about this Daraz thing. Daraz have very different scaling needs per domain. Let's say if a sales comes in, so I'm just trying to explain you it using the Daraz as a as subject, but you can try mapping it to any other system. Let's say the Daraz is getting a sale. So what is going to happen? The search service is going to get hammered during this service. Like tens of thousands people might be searching. They might not be like buying it, but at least they are searching for it. The payment needs to be very strict compliance and isolation. And if there is a monolith, any search service, if it got bogged down, everything else will be bogged down. So this is the reason microservices is going to be there. So they either scale independently or they can fail independently. So the trade-off, again, I just mentioned, like there are like couple of other things you need to add. Operational complexity is going to be there. You need to deal with the eventual consistency within the microservices as well, because if there are going to be different databases, so you need to, for to keep a specific transaction properly registered, you need to see those trade-offs. Then comes the MongoDB. So product listing are like, as I mentioned, widely heterogeneous, a phone address. So if we are going to use the SQL schema, again, the alter table is going to be very difficult, and document model help us like keep each product in well shape. And again, you can see for we are using Postgres or any RDBMS for any transaction like order, payment, user related thing. And every product is going to be a document. Again, as I mentioned, for the MongoDB, joins are not that easy in a document database. So if you need to have certain other data, what you used to do, you used to embed that product into that order document. And consistencies, asset level consistencies are a bit weaker in these type of systems. And even the searching is still offloaded to another like thing like MongoDB do have a basic search, but it doesn't provide that much at a scale which Elasticsearch is providing. So you can think like Elasticsearch is the read optimized search layer, where you can think like MongoDB is just the source of truth having the actual data. Then talking about the Kafka, let's just go through an example. User just place an order. What does the order service would do? The order would directly call payment, then inventory, then notification. So it need to call all the services in like synchronous way, or it have to wait from for the response if there is no Kafka. But if a notification service is down, the whole order will fail, or at least it will be failed partially in a sense. And if uh, but if Kafka is there, what does actually happen? Order service just emit an order placed event to the Kafka service, and each downstream service is going to consume it independently at its own pace. So it gives us a fault tolerance. This is the main thing you need to know about. Fault tolerance, readability, and a natural audit trail is the main traits of Kafka. Then comes the Redis layer. There are the three main use cases. One is the session storage. Usually the user login stage and the session storage are there being maintained in the Redis. Any sort of hot products when I say, like rather than like caching all the products which are getting searched very quickly. Any top seller page, it should not be on the DB. It should be within the cache. So at least you are going to get a quick cache retrieval. Then comes the rate limiting. If like our API gateway or our services are getting bogged down, the rate limiting will help us rather than getting our system bogged. It will just ask the user to try later at another time. And at that point of time, the system might have recovered. So this is the reason for rate limiting. So the RAS, if I talk about the RAS, without Redis, every page view is a MongoDB. So then comes the Elasticsearch for search. So like in when we are going to ask or use a SQL serve like query, so it just asks for like ampersand phone and this percentage phone sign. So it doesn't give you exact relevance ranking or any sort of typo tolerance. If let's say we just skipped O within the phone, it might not bring the records, or it doesn't bring faceted filters like by brand, by price range. We need to query other things to get that. But Elasticsearch is itself is a purpose built for this. So you just sync data from MongoDB into Elasticsearch asynchronously. There is another way. I'm not going into the technical details, but just to have a high level overview, we are using this. So the catalog DB isn't burdened with search queries. It is going to be get searched from with the Elastic searches. And API gateway, as we have discussed, the single entry point, it handles JWT validation, and it's also do the rate limiting, and every routes to the APIs for like order service, search service are going to get through, and even A/B testing if needs to be done, it is done at this layer. Then comes like breaking down the each component again, like user service. Let's go in a bit deeper in the services aspects. So user services, what it's going to use, like it's allow us to for the sign up, login, profile, and it we use like JWT token for authentication. Then comes the product catalog service. What does it do? Like seller upload a product and it do have a name, price, image, but everyone is going to get being a different from other. So different attributes are being used, and for that MongoDB is being used. And within the order service, what actually is happening, order needs to be permanent, and it's going to be a very important data where we need to be very sure about its reliability. So for this, we are going to use the Postgres data. So what does it do? Order service publish an event to the message queue saying a new order is placed, and other service listen and react. Then comes the payment service. So the main critical part for a payment service is that once it's being integrated, the payment must be idempotent. Idempotent is one more thing which you need to be well aware of. It means if a payment have been tried once, so if I retry it again, so the system should not return me another transaction. It should return me the same. Like it should not charge twice for the same call. So this is a thing which is very important when we are performing any financial transactions. So this is one thing. Then comes the search services, which we have already talked about. Then come the notification service. It just send the email notifications. So these services are there. So again, as I already mentioned regarding the databases, that we are using two type of databases in this system, not just one system. So not just one system can serve the whole purpose. So you can see we are using for users and orders and products, we are using Postgres. But for session and cart, we are using Redis, which is a cache, not a exact database itself, but it's a cache, a middle layer between these databases. Then comes the product search and index. That this is a part of the Elasticsearch, which is for like searching. And if we need to place the actual products, that is going to be within the MongoDB, which is not written over here, but actual products listing and products are going to get saved within the MongoDB. And then comes the product images. Those are going to be served via a S3 bucket or CDN rather than saving it within the same location or using the same service. And then comes the service to service events, which we have seen like Kafka. Then comes the scaling part. So if we need to scale it, there is going to be load balancers being introduced. What does it do? Let's say if our search service is not able to serve uh, 5 million searches, so we can have some parallel instances of those like search services. So with this horizontal, there are like two concepts. One is vertical scaling and one is horizontal scaling. So in one, you are going to upgrade the RAM, a CPU, and with this, you can like serve more requests within a single system. But when we are talking about like horizontal scaling, so we are going to set up multiple services next to each other. And what does a load balancer do? It serves or hit like service A in a round robin fashion. Let's say you have to divide a task between five of your teammates. So if five tasks come to you, you are going to provide one to each. Rather than just sending all the tasks to a single resource, you are providing it to the rest of the resources, and you are not overwhelming and overburdening a single resource. Then comes like again, as I just mentioned, the horizontal scaling, and again the caching have been discussed, CDNs have been discussed, and one more thing, it's being served at a like in a very physical server which is way close to us. There could be multiple CDNs. Let's say if we are serving it from Karachi, Lahore, or Islamabad, or might be from different regions, either US or Australia, Japan. So different CDN will be serving those requests. Then comes the database replication. This is again one of the good thing. You need to have proper replication and one primary database for the writes, and for reads, multiple replicas can be used. Now I'm going to come to the interview tips. I've explained you the whole Daraz system in detail, and I wish you might have got a good feeler of it. Feel free to leave it any comment or anything which I've missed in the comments, so I try to improve it in my upcoming videos. So interview tips, you need to always start with the requirement. Don't just try answering the question. Think out loud. People want to see you. Either you are able to think or reason. You can see if reason about a thing, if it's working or not, and what could be the other reason. Then you need to start simple and then scale, because there are two aspects. One is the technical aspect and one is the business aspect. When you are dealing with the business, they want to see the results as soon as possible. So you need to initially start with a very simple MVP, but you need to have a large scale level thing in your mind. So you need to design the basic version and then you can keep on adding the complexity. And again, you need to know your trade-offs. Then comes the right vocabulary. As I just mentioned, using the API gateway, the microservices, CDN, load balancer, message queue, these should be at your tips. You should have to use it in your interviews. Let's just take an example again of within the Daraz. If let's say a spike happens, what are the two type of critical problems can happen, like overselling? Overselling, how it can be done if like for some reason two users selected one record and both have seen it being available, and they try to get or buy that product. So we need to have a mechanism in place like optimistic blocking, and same can be intermingled with the Redis and Mongo or Postgres combination. So these are the things which you can use. And traffic spike absorption, which we can like do using the queue-based chart flow, which we have already seen. Then comes a more technical thing which have been like used, and this is mostly used in microservices. Microservices are more of a distributed transaction. Let's just run. If a user place an order, so you need to first what you need to do, you need to reserve the inventory, then you need to charge the payment, then you need to confirm and send notification. So these are all four services. So if a payment fails, what you need to do, you need to unreserve the inventory so anyone else can buy it, or the same user can buy it in another order. So this Saga pattern itself solves this as a sequence of local transaction, each published as an event. Let's say if the four services are doing, so each will be publishing an event within the Kafka. And if any step fail, any compensated transaction like roll back the previous step. So failed transaction or failed payment will be doing a inventory release event automatically. Then comes the media storage thing. Like for listing, I've already mentioned, rather than saving it on the same location, you can use a specific cloud based like S3 compatible object store, AWS S3 or any equivalent. So it can help you with any load being transferred or shifted to any other CDN network. And one more thing, when a seller upload, what does a background job or background worker or service would do? It would generate like multiple sort of thumbnails, either a thumbnail, a card, or a full image. All those variants have been like created and they have been saved on the CDN network. Now, this is being done once and we do not have to do it every time. With this being available, it's going to serve a quick purpose and it is going to save us time. But you have to choose it very effectively, because if you are going to you should uh, have to use or think through the costing perspective as well. So it's again just to give you like idea that now comes the product document. So it's MongoDB itself is just using URLs and the images are part of the CDN. Then comes the replica for the catalog. So let's say if the sale is there, so most of the people are reading or viewing your pages. So this is going to be a read intensive and writing. Like there are very few sellers who are going to update their listing because they might have done it upfront prior to the getting the sales on. So all the reads will be served. If all the reads will be served from the main DB, it's going to be very wasteful and risky. So what does it do? We create or like read replicas. So all those type of read having or read requests being sent to those read replicas. And one of the major thing which I came or which is the main aspect which we usually do not discuss is observability. Previously, we used to say that when we need to investigate any issue, we might be using logging. But with this observability, it is very helpful in these type of distributed transaction. Let's say if your system breaks at 11 p.m. So what we are going to see, we need to see or have a proper distributed tracing mechanism built in within our system. This Jigger or Zipkin are a different type of open source system. So let's say we have 6 services. So these systems, if we have integrated those, it can help us track down any specific service where the issue is happening. The second thing is like a central logging, ELK stack, which we have like seen already, Elasticsearch, Logstash, and Kibana. This is itself a stack. So all the logs are getting inside a specific place, and the metrics and alerting, Prometheus or Grafana. These are the dashboards for any failure, payment latency. So this is a next level thing. If you are well aware of this, this will add much value to your interview and helping you answer these type of questions. So without observability, you might not be able to track which service is getting bogged down and where the actual problems are happening. So this is something you need to keep track of. So I'm very hopeful that you might be like able to learn or at least get an idea of the things which I have faced over a period of time, and the way I've explained and tried to explain it might be helpful to you. So if you feel certain other topics needs to be discussed and addressed, feel free to share it within the comments. And if you like this video, so feel free to like the video and share it in your circle. And for anything which you want to ask, so feel free to comment below the video. So thanks for watching. Have a nice day. Bye.